Good morning. In the previous videos, I talked about air handling units. Today, I want to talk about the motors which drives the fans. Regardless what type of fan you're going to choose, fans are using motors, and motors are controlled by variable speed drivers, soft starters, or contactors. You can wire a motor in DOL or star delta if you use contactors. Today I will talk only about contactors, and then I will make specific videos for soft starters and variable speed drivers. Let's take it slowly so you'll understand. Like I said before, amongst other parts, the air handling units have fan motors, and they have to be controlled either by variable speed drivers, like you see in this picture, or maybe soft starters if you don't have to vary the speed of the motor, or the contactors. And as I promised today, I'm going to keep it simple. Here's your contactor. Now let's see how the contactor works. The contactor have an electromagnetical coil, so anytime that will be energized, the shaft inside the contactor will be pushed by the electromagnetical coil, and the switches which allow the three phases to pass by will close the circuit. It's simple as such. So here's your contactor. Now let's see. We want to build a DOL, direct inline start. That's a bad one. Anyway, if you want to build that, first you have to choose the motor. Then you have to choose a contactor that have the capability to support the motor load. Also, it's a good idea to use a motor circuit breaker to protect the motor. Going further, you need an isolating switch, because sometimes you have to repair the motor. You have to be safe. Then you have the main circuit breaker, which protects the wires, not the motor. So here's your circuit. Now you need a form of control. Could be either switches or could be a programmable logic control. Let's talk about poor design circuits without motor overload protection. You'll see in this picture we'll have on our circuit a circuit breaker, an isolating switch, a contactor, and the motor. There's not motor overload protection integrated into this system, and the circuit breaker protects the circuits, the wires, not the motor. Let's see why this specific arrangement it is not healthy. Look into this picture, you'll observe you have the isolating switch, two circuit breaker, power and control, contactor, and the motor. Let's see how this system works. We will turn on the isolating switch. The electricity will reach the power circuit breaker and the control circuit breaker. If we turn on the power circuit breaker, the electricity will reach the contactor. And if we turn on the control circuit breaker, the electricity will reach the switch. So now our system, it is standby to run. So we'll energize the contactor and the motor will run. Until here, the customer is delighted. It saved a lot of money, but this is a shortcut. I don't like this job. If you'll have a mechanical failure onto the motor, maybe you'll have an unbalanced phase due to loose connection in between the contactor and the motor, or maybe the circuit breaker and the contactor, anywhere, there won't be any overload protection to protect the motor to turn it off in time. Finally, if the running amps will go too high, the circuit breaker will turn off the circuit. But by that time, the motor could be already burned. This system allows the control circuit to remain active if the power circuit will fail. Now let's look to another type of system in which the control circuit loses power if the power circuit breaker will trip. If you remember, in this previous version, the control circuit is wired directly through the isolating switch, and it will remain on if the power circuit of this circuit will fail. Now if you choose this version, what you'll observe, the control circuit, it is wired through the power circuit circuit breaker, and if the power circuit breaker will trip, it will interrupt the power to the control circuit breaker. So the control circuit will be inactive as long as the power circuit breaker is tripped. You can follow this diagram. Now I don't like either of these choices. I have a different way, but I work on a system which unfortunately was wired this way. Now let's see what faulty contactor can do into your wonderful world. In the morning you come to work and you will go with your routine. You press the switch. You might want to start a pump or a fan or anything, but nothing happened. You try to energize the contactor. Contactor is energized, but contactor doesn't work. Why would that happen? It could be a solenoid burn, it could be a mechanical fault of the contactor, it could be anything, but that will put stress on control wires, and the circuit breaker of the control circuit might trip because you might have a short circuit on contactor's solenoid, and the right thing it is the circuit breaker to trip. What do you have to do in this case? You have to check the contactor. Look, here's your contactor. You have a solenoid. If you check the resistance between A1 and A2, you might not have the right value. You also have to check for mechanical damage. You see this. In a real world, contactor look like this. You have to check in between A1 and A2 the resistance, and also you have to check for mechanical damage, and then you have to investigate the reason why you had a mechanical damage, or maybe why your solenoid burned. Maybe you have a loose wire on a power circuit, and when you convert the electricity in heat, maybe you cooked the contactor. That will be lack of maintenance. So this arrangement is not very good. You see, you have a circuit breaker, you have an isolating switch, contactor and the motor. I don't like the system, but if you will cut corners and you'll do a cheap job, the customer will suffer. Let's see deep what can happen in this situation. You can have a voltage drop in any of the three phases, and that will happen because of loose connection or damaged blades inside the contactor. Let's see what happened inside the contactor, so we have a little bit clearer view about the potential faults. So let's say we have a voltage drop. Look, here it is in between the contactor and the motor, or maybe from inside the contactor the blade is damaged. So maybe the entire blade is damaged inside the contactor. Then you convert the electricity in heat, and that will cook the contactor. Or maybe from the circuit breaker to the contactor you have a voltage drop because of loose connection on the wires. If you have one phase that loses its voltage, the other two phases will struggle, and the running amps will increase until the point where the circuit breaker will trip. But by the time the circuit breaker trips, your motor might be burned. Now it's time to leave behind these circuits which are not equipped with motor overload protection, and focus on circuits that are equipped with motor overload protection. Let's see the benefits of having this overload protection, and also let's understand how this overload protection works.